the first part here, this is just to add the average acceleration. I talked to groups about acceleration yesterday when you were doing the activity. So whatever I was saying to you is pretty much what I'm going to have up here. So acceleration is the rate that your velocity is changing. As long as, and if you're looking at things all in the same direction, I guess you could technically throw it into speed, but really by definition, the acceleration is affecting your velocity. Because just like velocity, acceleration has a direction to it. So you can have positive and negative values to acceleration. And what I'll have up here in a second is negative acceleration does not necessarily mean the thing is slowing down. Because again, the positive and negative are all based on the direction you're going. Okay, because it's a vector value. Anything that's considered a vector, because vectors have direction to them, is going to have positive and negatives related to their direction. All right. If you want to write like some kind of formula down for this, if you notice, it's the same formula that you would have had for like velocity. It's just instead of velocity being displacement over time, acceleration is velocity over time. Because a rate is always a division, so it's meters per second. Your units for acceleration, and here I'll write all of them out over here. Right, your displacement units should be meters, or just M. Markers die. For velocity, your units should be meters per second, or you just write ms. And if I threw the units in here, this is like meters per second. But just to simplify that down, so again, meters per second. It's talking about how much your velocity is increasing over time. So your units are, when you write it like meters per second squared, or you'll see it as m divided by s squared. So if you see these units are talking about velocity or speed, obviously if it's just an m or some kind of variation of that, you're talking about a length or a displacement. And anything with the m on top and the second squared on the bottom is some kind of acceleration. Or any kind of time. Obviously I'm putting up there the SI units. I could put, if it was some kind of, I don't know why they do acceleration in like kilometers per hour squared, but obviously you could do it. The bottom just has to be a length of time that's square, and the top has to be whatever unit you're using for your lengths or your displacements. All right, so just to kind of have in words for you what I've said about the negatives and positives, but I got to keep, this is something that has to be like rehashed and like driven into your head with this. With velocity, it's not as big of a deal because people have an easier time grasping the difference between positive and negative velocity, getting the idea that positive is something moving toward the right and negative means it's going to the left. Acceleration is a little bit different from that because I can have motion going to the right and acceleration going to the left, and I can still be moving to the right, and it kind of throws you off a little bit. But you do have positive and negatives. All that it means is when it's negative, that means that you're moving your velocity in like towards the negative direction. So if I start with a velocity going this way, and I throw like a negative acceleration in there, all that this is doing is it's going to start shrinking that velocity until it then changes to the other direction. This is what I'm saying. I could still continue. So let's say this is at the start. If I go 1 second, it's going to shrink down to here, but this will be after 1 second. I'm still moving this direction. I'm just going at a slower pace. Then if I go another second, I would cut it down a little bit more. So we'll say that's after 2 seconds. And then after 3 seconds, I would be momentarily stopped where you're changing direction. and then you would start going in the other one. So this is a much harder kind of idea for most people to wrap their heads around. Like I said, velocity is a little bit more straightforward because positive means to the right, negative means you're moving in that direction to the left. Whereas all the acceleration one means is that your velocity is changing in that direction. Because again, people want to say if I have a negative acceleration, I'm decelerating. That doesn't mean you are. Like in the picture down here, if they start moving this way, that's in the negative direction. And if I throw a negative acceleration to it, I know it says positive or negative, but I'm doing with our normal movement. If I throw like a negative acceleration to it, that means that this is going to start increasing because they're going in the same direction. So there are 5 variables up there. There's 4 different equations. As long as you are dealing with a problem that has constant acceleration, and I'm going to have that like in big bold letters on the next one, on the next slide, because if it's not constant acceleration, there's got to be some other way to do the problem, which you're not at yet, but eventually you will. Okay, when you throw like forces in there and deal with energy problems and stuff like that. But as long as I've got 3 of these, I can find the other 2 that are missing. Okay, so out of those 5 variables, if I give you 3 of them, you can find the other 2, and you can answer pretty much any equation that you guys need to, or any problem that you need to about kinematics. So you can find initial speeds, or initial velocities, final velocities. I can find accelerations. I can find how long the thing's in motion, how far it goes over a certain amount of time, so on. Okay, which is like I know that if you deal with average velocity and time, I could find out how far something goes over time with an average velocity. But when you start throwing accelerations in there, you're going to have equations that are a little bit longer. But as long as you guys keep this somewhere that you can get it like ingrained in your head, and you keep yourself very organized on the problems, then there aren't too many issues that come up unless you just screw up the arithmetic part of it. Okay, can I go past this? All right, so all these are going to be in the following equations. All right, so this is the first one. This one you will use. Okay, out of these 4, like I said, there's 3 that you use. This would be one of them. And what will happen is, I'm telling you, this is one of the easier ones because it doesn't have, like some of them have squareds in them and 1/2 and stuff like that. But when you get into problems, sometimes people forget about some of the easier ones, or even the ones that we did the first day of notes with like average velocity. All that stuff's still going to apply to your problems. All right, so what happens is people start overthinking things when you start presenting more. All right, so again, the way you'll know how to pick the equations that are going to be up here is the problem's going to ask for a specific variable. Like they might say, what's the final velocity of something? But like in this case, they would give you an initial velocity, an acceleration, and a time. Okay, so when you're dealing these kinematic problems, you're going to have, or at least have a way to find 3 of the variables. All right? So what you're going to have to do to keep yourself organized is you need to write out what 3 you're given. Like I would suggest writing out the letters for the things that are given to you in the problems. Write out the letter for what's missing, and then just match it up to which kinematic has those 4 in it. Because each one of these are going to have 4 variables in there. Okay? And there's only going to be one of these that match up to the 4 that are given to you in the specific problem. So again, like on this one, you've got to have something involving final velocity, initial velocity, acceleration, and time. This one is actually like your average velocity formula, just written out separately. So this one here, I include, like it might not be included on some things, but I'll include that because a lot of people forget about this one when you get into other problems with acceleration. Okay? So this part, like this section right here, is like your average velocity. So starting velocity plus your final divided by 2 is going to give you that average there. So it's actually a formula that we did on the first day, or that I had on the first day. It's just written in a different format here. The next 2, you're definitely going to use quite a bit. So now again, like I said, if you notice, again, all of these have 4 variables in there. All right? Like your job is going to be having to go into the problems, write out the variables that are involved in that specific problem, and then matching them up. So like this one would have to have final velocity, initial velocity, acceleration, and displacement in there. And if they only give you 3 of them, and there's only 3, there's probably nothing to really solve for, or there's going to be a real basic way to solve it. All right, and then that's the last one. All right, so here's the first one. Okay, so if I was reading it, I would understand I can use the kinematics. It's a constant acceleration because it says it accelerates at a rate of 2 meters per second squared, and it's saying it's not giving you an area where it's saying that's varying at all, so I know it's a constant acceleration. Okay, so what I would say and suggest you do is go through each of the problems. Even when we get to sections that don't involve simply kinematics, like if we get a few chapters down the road, this stuff is still going to apply. If we get a few chapters down the road, I would still go through the process of writing out all the variables that are there, because you are going to have to use these throughout the entire course. All right, so if I just start at the beginning, this is saying a boat's traveling at 6 meters per second. So if it's already traveling at 6 meters per second, that's telling me that is my initial velocity. So I know I can write that off to the side. Look, I know I've got that given to me. Okay? So that means the equation that I pick out of those 4 equations has to have that variable in there. So if there's one that doesn't have that in there, then you can just eliminate it. Then it says it accelerates at a rate of 2 meters per second squared. So I've got my acceleration. So I've got that. So now I know at least the equation I'm picking out of those 4 have to have at least those 2 in there. So if you've got one that does not have initial velocity and acceleration in there, just cancel it out. It's gone. You don't need that one. Then my next bit would be time, because it's giving me 8 seconds, which is a time. So I got to have that in there. And then the actual question is asking how far does it travel? How far does it travel is the displacement, so I got x. So you need to find, there should be one equation that has all of those in there at the same time, out of those 4. So if you write them out and then look at your list, like I said, there should only be one that has all those in there. Correct? Is there one that has all those in there? I don't look at the sheet. Look at your equations. Tell me. I know you didn't do it, man. I don't know. What's it? All right? Don't break anything. Which one? Read it to me. Nope. What's that V right there means final velocity. I don't have that. So I can't use that one. Which one are you going to say? Yeah.
The last one, x equals v0 t plus 1/2 a
T squared, yeah. Okay. So that's the one I'm going to use. Because look, it's got initial in it, it's got acceleration, it's got time, and it's got my displacement. Okay. All the other 3 would have something that is dealing with final velocity, which I do not have. So all the ones that have final velocity in it would get canceled out. All right. So once you get, you write out your variables, you pick your equation, and then it's just a matter of plugging in all the numbers. Make sure you don't screw up order of operations. Okay, so my initial velocity was 6.0 meters per second. Time was 8.0 seconds. What's that? Yes. And what was T again? 8. Okay. Now, if I want to be nice and neat here, I could do my canceling of the units. But chances are, I mean, it's going to be left with meters, because if I did this, this second is on the bottom, that's on top, so those go away. This is second squared, which cancels out that second squared, which is the reason I'm left with just meters, which is what I want. Okay, but I'm not too worried about that. I'm more worried about you guys making sure the numbers are correct. So what's 6 times 8? What is it? 48. I'm going to do this part separately. What's 8 squared? 60 what? 64. So what's that? Half of 2. 1. So I've got 64 there. And what's 48 plus 64? 112 meters. If you're still working on it, it's fine, but the equation you guys should be using is the one that's the v squared. Should start with that. It's 2ax. Okay, because it's asking to find displacement. Anytime you're starting from rest, kind of makes life simpler because you got a 0 to plug in, so essentially you can get rid of it. So that's 0. So on my next step, I'm not even going to write it. So v squared is 62 squared. I don't need that. Let's watch. You'll see some of these examples come out like this. What was the acceleration? 31. What's 2 times 31? If I do 62 squared divided by 62, what's that become?
3,000.
If you divide them out.
Divide them out?
Yeah.
Oh.
62. It's just, math stuff. So displacement should be 62 there. But again, like I said, you need to write these out, compare your equations, make absolutely sure that the one you pick has those 4 in it. If it doesn't, and you pick the wrong one, eliminate it, go to the next equation. Okay? All right. All these have been horizontal. I'm going to do a couple with the vertical just to talk about the way acceleration is going to work here. If we do things vertically up and down, the way you treat these, you use the exact same equations. You might see them written different if you look like in a book or something. The only thing that's really different is instead of the x, they might use y for displacement, but it still represents displacement. So if I give you problems where I talk about something going up in the air and it's got a specific acceleration and that acceleration is going for the entire span of that problem, you do it the same way as that one. If you're talking about a free fall problem, meaning that something starts in the air and just gets dropped, where the only thing accelerating it is gravity, then that constant acceleration always has the same value, which, what's the accelerate? Do you guys know it? 9.8 meters per second squared. All right, so this is only with free fall problems, is you're going to keep this as your acceleration. So if you're dealing with a free fall, the value for A will not be given to you. It's right there. It's understood in the problem. If you throw something in the air, that counts as free fall. If you're dropping something and it's going in the air, it's free fall. Okay, the only time it does not hit that acceleration is if they say there's something acting on it either behind it or up it to thrust it in either direction, which you're not doing forces right now, so we're not there yet. If you're dealing with something in the air, it's in free fall. Okay? Meaning that the problem that's up there, where it's asking what's the displacement of the stone, again, this is kinematic equation because it's a constant acceleration. The constant acceleration is the acceleration due to gravity straight down. I've got an initial velocity, because again, if you're dropping something, they're not going to tell you the initial velocity is 0. You're dropping it. I know it's starting from rest in your hand. Okay? So I got an initial velocity. They give you a time, which is right here. So if I just went through the problem, I would see that, and I understand that they're asking for, it's a y, but this is the same as the x, so it's a displacement. So there is going to be people that, until you get used to it, there's a lot of people that are going to say there's only 3 variables there. I can't do anything with the problem because you said I needed 4 variables to pick an equation out. Okay? This is where you got to remember, hey, this thing's acceleration. I do have acceleration. Do you want me to do 9.8 or 10? 9.8. So this thing is 9.8 meters per second squared because it's gravity. Okay, now, here's another thing that will kind of mess people up because, again, this all is a frame of reference. The way this is moving, I'm starting up here and I'm going down. The acceleration due to gravity is pulling it down towards the ground, correct? Right? Gravity pulls things towards the ground. Yes? Throw a negative in there. Just keep everything in the context of what the problem is. You'll see that there's going to be some times where you want to be positive, sometimes be negative. It all depends on the context of the problem. Your frame of reference is going to change what you're doing with that. But since they're defining here very nicely that up's positive, down's negative, I know to put it there. All right, initial velocity was 0. Time was 3. Was at 0, seconds. And I'm trying to find that. So which one of the ones has those 3 in it? I need one with acceleration, initial velocity, time, and displacement in there. We already used it. Which one was the equation with it? Yeah, times. Times squared. Okay. All right, now I know we're finding y here, but y and x, like I said, are interchangeable because they both represent displacement. Y is just the vertical displacement as opposed to horizontal. So if I took what I got and plugged it in, all right, so that's a big 0 there because that's a 0 meters per second squared from my initial, so I'm just going to drop that out because I don't need to rewrite it if the 0 cancels it out. So negative 9.8 meters per second squared. Oh, 9. What am I doing? I'm squaring it already in my head. I should get a negative number. It makes sense in the context of it because I'm starting at a 0 point that's above the ground and I'm going to the ground. So that means I'm following a negative displacement. So negative makes sense for your context here. 3 squared is what? 9. What's half of 9.8? 4.9. So I need 4.9 or a negative 4.9 times 9. What's negative 4.9 times 9? I don't know what it is. You trying to do it in your head? Okay. You're just staring at me like I'm not going to do it in my head. What? 44 point what? Yeah. Okay. So an answer here would be either leave it as negative if you feel more comfortable with a positive number for an answer. You can do it, but you have to add the context of going like it's 44.1 meters below where I dropped it. You have to actually say that it's going down. Okay, because if you just say 44.1, that's going to be assumed that it's up or to the right or something like that when it really isn't. Okay? All right. One last thing to talk about before I give you the work and you got the rest of the time to do whatever. Okay? Answer me that. Read it. Look at it. Talk with each other. Figure it out. I'll tell you if you're right or wrong. All right. You don't know what's going on. This is someone, we'll just say whatever it is. What is it? A pellet. So someone shot one up straight in the air at 30 meters per second. It hits a peak where it can't go any higher, then it turns around and comes down. Here, they're shooting it straight down at 30 meters per second. The other one's greater? I don't know. Talk. Figure it out. You think they're the same? You got to be able. Either way, you got to be able to back up what you're saying. Math. No math, man. Why? All right, hold on. Why do you think this one's faster?
Because it went from a higher.
Because it goes from a higher point.
Yeah.
All right.
Well, it kind of depends on how.
Wait, hold on, I'll come back.
I think speed is faster.
You think this one's gonna be faster?
For sure.
Because we're shooting it straight down.
They would have to go up,
Yeah.
slow down, and speed up, gravity.
What are you gonna say, Steve?
I think they're the same, but kind of different on the height.
Same height.
Wow.
200 meters. They're both from the same height here. This point right there is the same height. What are you gonna say?
I think they're the same because, like, you said he drops it on the ground.
Here?
Yeah.
Like it's going. You're launching it straight down the ground.
If you're launching it, I guess it depends on how strong.
No, they're strong enough to hit it at 30 meters per second. That is the speed. Why?
Because they're falling at the same speed.
That's accelerating. They're accelerating at the same rate. Yeah.
Are they the same? Say yes or no.
just tell me. All right. The thing that's going to matter is what speed this one over here is when it hits this point. Like when it goes up, stops for a second because it's remember as soon as it's going up, it's in free fall, so you got gravity trying to pull it back down. So it's going to reach a spot where it's momentarily stopped, and then it's going to start accelerating back down. Right here is all I care about because this is my initial velocity going down here. So I need to know what this initial velocity is going down there, and then I can make the decision from that. What do you think this number is right here? No, that's acceleration, not velocity. So your acceleration is the negative 9.8 meters per second squared. What? All right, you guys did algebra, right? Yeah? It doesn't matter. This shape right here, what's that kind of look like? Parabola, right? If I drew a line here, what happens on each side of the parabola? Like if I put a number here that was 2, what's this over here? Huh. Symmetrical, yes? Same thing happens there. This is 30 right here, what's this? They both start with the same, from this frame of reference, from this level, do they both start with the same velocity there? They're going to hit the same speed, man. Okay? The only thing that matters is when this thing is going down, the speed at that moment when it starts hitting the same point where that one's going to start traveling down. And at that moment, they both have the exact same speed. They're both accelerating at the same rate. They both have the same initial velocity. They're going to hit the same speed. The only way that could be different is if this number was different between the two.